Sorry. Okay, so we talked about frame of reference in class. Sorry about that, Sean. Okay, frame of reference is the object, the background, whatever it is that you're using to prove to yourself that movement is taking place. So many times it is the earth, or you're using yourself, which you're standing on the earth, which is moving, so you're using the earth as the frame of reference. Okay, so it gives you this example. You really have to imagine, okay, and if you need to on the test, draw out what's happening so it makes sense. A train takes off with you in it. So the people that are standing on the ground, the train is moving compared to the earth. To you, it's moving based on the platform. Like it almost sees it's the train because the train is what you're sitting on, and so you notice the movement based on the train. Okay, so we'll practice this more in class. This is one that's not easy to understand. Okay, we showed this one in class. We noticed that the lemon is standing still in each of the pictures. It's sitting on a platform, and that's how we know the bullet is moving through it. All right, so motion, you've written this down already. A change in position in a certain amount of time. The way we calculate speed is distance divided by time. We did our airplane lab. You all have calculated speed many, many times. All right, so I'm just going to skip those. We're going to continue to practice in class. Okay, constant speed. It says when the speed of an object does not change. The graph is always a straight line. However, this graph over here is actually not correct unless we add a straight line this way. Oops, let's imagine it's straight. Okay, so imagine that's a straight line. I'm trying to do it with the mouse. That would be constant speed. Okay. This blue one would actually be acceleration. Okay. All right, over here we have average speed. A normal person driving is going to look like this. They're speeding up and then they slow down. They speed up, they slow down. Once you put it on cruise control is when you're going to get this perfectly straight line. Okay? All right, so let's keep going. Velocity. Remember that velocity is when you just add direction. Okay, am I going east? Am I going upstream? Am I going downstream? In this picture, you're combining velocities based on the movement. So if I'm in water that's going 10 kilometers per hour right here, and it's going with me, it's going downstream, I'm going to add them together because the water's helping me go faster. I'm actually going 26 kilometers per hour. If I'm still rowing with my arms 16 kilometers per hour as I was up here, but now the water's going against me, I'm going to subtract it, and now I'm really only moving 6 kilometers per hour, which makes this guy super exhausted. Okay, so let's skip that. Acceleration, everyone's favorite. Just remember the definition, the rate of change in velocity. So velocity is what's changing. That means either the speed is going up or going down, and also it could just mean that you're changing direction. So anything that is in circular motion, a Ferris wheel, carousel horses, that's going to be constantly accelerating because you're changing direction. The way that you find it, I will give you this formula on your test, is the final velocity. So we're talking about the speed of the moving vehicle or whatever it is that's moving at the end. Final meaning ending. Original is starting, okay? So final velocity, subtract original velocity divided by time. Here's your example. A car is traveling 60 kilometers per hour. It accelerates to 85 kilometers per hour. So it went from 60 to 85. So final would be 85. See, I put it over here. Oops, and then I have 60, which was my original velocity. So when I subtract them, I get 25. Divide that by 5. And so over here, my answer is that I am speeding up 5 kilometers per hour every hour. You're going to have 2 time increments. If the number ends up being negative, it is decelerating. We call that negative acceleration. All right, so acceleration shows going up. Whenever you see it moving down, it is decelerating. You should be able to recognize these graphs on the test. You guys practiced that last class. Okay, circular motion, it says constantly accelerating because the direction keeps changing. We just said that. Momentum is like how much power does it have, okay? So this is mass times velocity. The bigger something is, the more power it has, versus the faster it is, the more power it has. So if you have two things coming at you at the same exact size, the one that's moving faster is gonna have more of a punch. If you had them both going at the same speed, then it's going to be the size of the object that's going to matter. Again, this formula will end up being on your test, so you'll just have to plug in the numbers. So what's the momentum of a blue jay that has a mass of 5 kilograms flying 10 meters per second? And the answer would be 50 kilograms dash meters per second. You're going to have both units in your answer. All right, the law of conservation of momentum. Remember, the law of conservation of anything means what goes in must come out. So this states that the total momentum of the object stays the same. So if the momentum of the white ball here is, let's just say it hits it with 10 joules of energy. When it hits this ball, it's going to transfer exactly the same amount of energy. Alright, so it says a bus can have a large momentum even if it's moving very slow because of its size. So if you had a bicycle going 5 miles an hour and a bus going 5 miles an hour, you'd rather have the bike be the one that runs into you. Okay, so just think about it logically. Remember, this is all common sense. We're just putting words to it. Skipping that. Alright, so that's all of your notes. We'll watch some of those video clips in class. We're going to go over this again tomorrow, and then your test will end up being on Friday. Just keep practicing doing the math equations, lots of math in here, and then study the vocabulary. Okay, I'll see you tomorrow.